today we're going to start out with a review of finding the vertex from a quadratic equation in standard form. This is one way to do it. Okay, so we have our formula h equals negative b over 2a. So we're trying to find our vertex h comma k. So we're going to start out by using this h equals formula. Right? Remember that I need a, which is 2, b, which is 8, and c, which is negative 17. When I'm using my formula, I want to replace the letters entirely. So we see here I don't see those letters anymore. I'm going to replace them with parentheses, and inside of those parentheses, I'm going to put the numbers. All right, so b goes in that first set of parentheses on top, okay, because it's b, 8. And then on bottom, I have the second set of parentheses where a was, and inside of those parentheses would go 2, because that's my a value. If I take this and I plug it into Desmos with the negative and the parentheses and everything, I get negative 2. So my h is negative 2. Then I have to find k. Now k is a y value, all right, and this equation here is my formula for the y value for any given x value. That's basically what an equation is. So anywhere I see the parenthesis, or anywhere I see an x in my original equation, I'm going to replace it with parentheses. So notice I see 2 parentheses squared instead of 2x squared, plus 8 times parentheses instead of 8 times x, and then minus 17. Now inside of those parentheses, we are going to put the negative 2, our x value. We're going to replace it with that x value. I can plug this whole thing into Desmos and it will calculate the value for me. It is negative 25, and so my y value of this vertex is negative 25. So entirely my point for my vertex is negative 2 comma negative 25. And this is a way that we can find the vertex without using Desmos in the sense of looking at the picture of the graph. So without looking at the picture of the graph, this is how we can find the vertex. Today, though, we are going to look at a different way that we can find the vertex from a standard form equation. We're going to start out with looking at converting from standard form to vertex form using complete the square, and also solving quadratic equations using completing the square. So when I have an equation like this, I want to try to factor it. So when I would try to factor this, I would start with putting the x squared in that first box, the negative 1 in this second box, and then I would want to see what are numbers that multiply to negative 1. Well, really just negative 1 and 1. And I'm trying to see if they would add to 2. So negative 1 plus 1, does that equal 2? No. Negative 1 plus 1 equals 0. So I'm going to have a hard time figuring out a pair of numbers that multiplies to negative 1 and adds to positive 2. It is impossible. So we have to do something a little different. Instead of starting with the beginning piece and the ending piece and figuring out what goes in the middle, we are going to start with the beginning piece. We are going to see what multiplies to make x squared, and we know that that should be x times x. Then we are going to look at 2x. Now, if I'm looking at this term, completing the square, a square has the same stuff, the same numbers on both sides of the square. So I want both sides of the square to have the same stuff. I want it to have x plus or minus the same number. All right. So for that to be the case, I have to split up the 2x, the stuff in the middle diagonal, evenly. I want a 1x here and a 1x here, because that's 2x split in half really nicely. And when I do that, I will get a positive 1 here and a positive 1 here. Okay, now what that gives me in this last box, when I do 1 times 1, is positive 1. Now we don't have a positive 1. In our original equation, we have a negative 1. So I'm going to have to add or subtract something to this number, this positive 1, in order to get to negative 1. So to get from positive 1 to negative 1, I'm going to have to add a negative 2, or in other words, subtract 2. When I write my final answer, it is going to look like this. Okay, so this is what I get when I complete the square. And if you notice, this equation is kind of like another form that we've talked about before, vertex form. So we are going to talk a little bit more about this today. So when we are completing the square from the standard form of a quadratic, it is very important that we follow these steps. So you are going to want to write this down. We will start with x squared. We are going to put that into our first space. Then we are going to take our bx term and split it evenly in half and put it in these boxes. Then we will have x plus whatever 1/2 b is on both sides of the box. And in this last space, I will have whatever this number is here times itself, so that number squared. And then I need to figure out what I'm adding onto it to get to c. So from c, I'm going to use c to find whatever number I'm adding on outside of the parentheses, which we'll call d. And d is just whatever this number is, c, minus that 1/2 b squared term. So when I write it out, again, it will be written out as y equals parentheses x plus 1/2 b, close parentheses squared, plus d. And now this will be vertex form. So it is very important that we have this written down. Let's look at an example together. So if I start with this one, going in order, I will start with x squared. Then I will take my b term and I will split it up in half evenly. Now, -4 split in half is -2. So here I will have -2x, and here I will have -2x. So now this means here I will have x, here I will have x, here I will have -2, here I will have -2. Same thing on both sides of the box. Then I will multiply -2 by -2, and that will give me +4. Now, what I'm going to do to figure out the number that I add out here is I am going to take this c and subtract this b term from it. So remember, we had that formula that d term is c minus that 1/2 b squared term. So in this case, d is just -5 minus 4, which is just -9. So -9. All right, so at the end of this, I can write my equation as y equals parentheses x minus 2 squared, and then a minus 9 at the end. Plus -9 or minus 9, doesn't matter. But that is the end of that problem. Okay? This next one you are going to do on your own, and then you will check it with me as part of checking off your notes. So please try the next one on your own. All right, so now we'll look at the other type of problem, using this process of completing the square to find the roots. Now, roots is another way of saying x-intercepts, so you can make a note of that to yourself, that this just means x-intercepts. Okay, so first we have to go through the process of completing the square. So I will start with x squared, and then I will take this and split it in half. So I'll have 4x and 4x. Out here I will have x plus 4, x plus 4, and in here I will have 16. And then to find d, I have that d equals 15 minus 16, which is just -1. So my equation is that y equals x plus 4 squared minus 1. Now, when I am using this to solve for x, the x-intercepts, find the solutions, find the roots, however you want to say it, remember that my equation always has to be set equal to 0. So I have to take this, set it equal to 0, and then I can solve for x. So I will add 1 on both sides. So I get 1 equals x plus 4 squared. And then I will take the square root of both sides. Now remember, when I take the square root of both sides, square root of 1 is just 1. But remember, it is positive and -1. So this plus or minus is a way of representing that I get both the positive version of the number and the negative version of the number when I take the square root. And then finally, to get x alone, I subtract 4 from both sides. So I get two answers. I get that x equals -4 plus 1, and that x equals -4 minus 1. Right, so one of my answers is that x equals -3. And then my other answer is that x equals -5. So those are my two answers. And then you can try the next one on your own and then check with me. And that's it.